Hello, everybody. Joseph here from the ChronoLogic team, and I would like to welcome you to another live stream. Hope you guys are doing okay. Let me know if you can hear me. Just write something in the question box. So today, okay, thanks, Mr. Swiss. I see you can hear me. Perfect. So welcome to another live stream. Today we will be talking about something pretty exciting that happened on one of the hackathons recently where the ChronoLogic team participated in, and it is something called the stop loss mechanism, and it is a prime use case for our new Chronos platform, new Chronos Protocol, which has this option of conditional scheduling. So in this webinar, in this live stream, we will be going through the use case of this conditional scheduling, and we will demo basically what has been done on one of the hackathons at Melonport in that happened in Zug, Switzerland. So let's get right into it. So first off, let's start off with a couple of updates in regards to the Ethereum alarm clock tooling. So we have the latest release of the Ethereum alarm clock DApp, which has small improvements, mostly responsiveness optimizations, a couple of fixes with the search bar and the bounty estimator. You can find this at app.chronologic.network, or you can also go to our GitHub page, and on the GitHub page of the Ethereum alarm clock DApp, you can find the binary versions, so executables for macOS, Linux, Windows, what have you, and it's a minor update, but I think people will really appreciate it. And as we see with the version numbers, we're getting really close to a version 1 release, which is something that we are very, very excited about. So just to recap a little bit on what happened at the hackathon in Zurich. This was May 19th, and our developer team, Daniel and Logan, who is here with us today, they won the hackathon. They won the grand prize at the Melonport Hackathon for building a stop loss mechanism for scheduling certain actions based on this stop loss mechanism, and they used the Chronos protocol and the Chronos TimeNode to trigger these conditional scheduling. So what we want to do today is kind of give a short demo of how it all went, and so even you guys who were not at the hackathon or might not have understood what it's about, I think after today's live stream, you'll have a pretty good idea of the capabilities of conditional scheduling on the Chronos protocol. So I'd like to welcome Logan here. Logan is here with me. Say hi to everybody.
Hey guys, Logan here. Thank you for joining us on the live stream.
Yep. So let's get into the matter of things here. So maybe Logan, you can explain a little bit. You can refresh us a little bit about what the Chronos protocol is and what is conditional scheduling.
Yeah, so just so everybody's on the same page, let's do a quick refresher of what the Chronos Protocol is. So the Chronos Protocol is a next generation smart contract automation platform, which is kind of a fancy way of describing the scheduling features. So a big difference is that it's not the Ethereum alarm clock, but it was influenced and it was born out of the knowledge that we had as maintainers of the Ethereum alarm clock. The big difference between Chronos and the alarm clock is that Chronos adds this ability to schedule based on conditionals, on top of the ability to schedule based on time. So this is why we say like a smart contract automation platform, because with the conditional scheduling, we now have contracts that can read the state of other contracts and react based off of changes on the Ethereum blockchain. So as Joseph was saying, so this is the technology that we used during the Melonport Hackathon. We used the early version of Chronos as well as the Chronos TimeNode to demonstrate a stop loss. And I'll go ahead and walk you through that demo right now. If the demo is going kind of slow, it's because I'm using a remote computer. So bear with me. All right, so on one of these tabs, I'll go ahead and start the Chronos TimeNode. This is a JavaScript program. And it's available in our open source repos.
Yes, that's exactly what I wanted to mention. So.
Okay. So on the left-hand side here, I have the time node started. You can see that it's attached to a scheduler at a certain address, and it's watching an event emitter. And these are both contracts that are deployed on the Kovan network. So this is running live on the Kovan testnet currently, and this whole demo will take place on Kovan, as you'll see when we get to the Etherscan part.
Can you tell us a little bit about the difference between this Chronos TimeNode and the Ethereum alarm clock TimeNode? Do we have some notable differences there? And if so, what would they be?
Sure. So the biggest difference between the Chronos TimeNode and the Ethereum alarm clock TimeNode is that the Chronos TimeNode is aware of the conditionals, and so when it's watching a new scheduled transaction that needs a conditional, it'll start to watch the contract that is pointed to for when a state change happens. So basically what that means is that the Chronos TimeNode is watching more than just the scheduled transactions like the alarm clock TimeNode, but it also watches various other pieces of the Ethereum blockchain so that it knows when certain things happen.
Awesome. Thanks for the explanation.
So on the right hand side here, I'll start the demo. So the way the demo works is by creating a stop loss when the price of an asset drops below a certain threshold. So for the sake of illustration, we created a mock price feed that we're able to change to the price of so that we can quickly demonstrate the effect of a falling price of the asset. So there's a few commands that I'll be using for this demo. You can see them here. The important ones that I'll be using will be the get price, which will fetch the price of the price feed, change price, which will change that price, get offer, which will get the details of a offer made on the exchange, last offer ID, which will get the last ID that was made on the exchange, and the exchange that we'll be working with is the matching market at the Kovan address here. So if any of you guys want to follow along, you can watch what's happening on Kovan Etherscan by following this address here. I will, I'll post it in chat for you guys.
Perfect. And this matching market, can you explain just a little bit what kind of exchanges is it?
Sure. So the matching market is, it was the simplest exchange that we could use during the hackathon that was available to us from the Melonport contracts. So the way it works is essentially it's just an order book. So you can place an order. So you place an exchange that you place an order for an asset that you would like to exchange for another asset. Say how much of that asset you would like to exchange and how much you want to get back, and then you wait for a person to come and take that offer. So you can think about it as just a simple order book on the blockchain.
Okay, cool. And it's implemented in like a smart contract or something?
Yeah, correct. So it's a smart contract. It's in the Melonport smart contracts repository.
Okay, cool. Understood.
And we can get the last offer ID made on this matching market and see that it was 105. To illustrate a little bit better what this order looks like, we'll go ahead and view the details. So in this result here, the field labeled 1 is the address of one asset, and the preceding field 33 is the amount of asset that we would like to sell, and the next two fields are another asset and how much of that asset we would like to buy. So I believe in this example, this first asset is the Ether token, and the second asset is the Melon token. All right,
Okay.
so time to get to the interesting part. So let's actually set up the stop loss. And when that stop loss is triggered, what it'll do is create an order on this matching market exchange.
So when you say stop loss, you mean we want to set a trigger that if the value of one of our assets drops, that this value would be sold in exchange for another asset, right? Have I understood this correctly?
Yeah, exactly.
Uh-huh. Okay.
But one thing I forgot to do was change the price. So if we get the price, we see it's a low number. We need to change this to be above the threshold price, which is 100. So I'll
So this
set
is
it to
just an artificial
175.
price, right?
Correct. So this is just the mock price feed that we're using so that we can illustrate the stop loss feature, and we don't have to wait for the markets to move.
Yeah.
Okay, so now we have the price feed, which reads 175. This is above the threshold price. So because I forgot to do that before, let me just restart that time node. All right, so now when I set up the stop loss, what you should see is that the time node to the left will register that the stop loss scheduled transaction was created, but it won't actually execute that transaction until the price falls below the threshold.
So what is the exact threshold price at which the stop loss will be triggered?
So the threshold in this example is 100.
Okay. Okay. So that means if we artificially change the price to be lower than 100, the stop loss should be triggered.
Correct. So on the left here, you see that the time node has picked up this transaction, but it's saying that, and it knows that it's in the execution window, but it's saying that the conditional returns false because the threshold price hasn't been hit. So so to trigger that time node, what we'll do is we'll change that price so it's below the threshold. And once that's mined to the chain, you'll see on the left-hand side that the time node will execute this transaction. It says conditional returns true, executing, and executed. So if we take this transaction hash and look a little bit deeper on Etherscan,
Keep in mind that this is running in the Kovan test network, so we have to go to kovan.etherscan.io in order to find this exact transaction.
correct. I posted a link in chat for anyone who's following along. All right, so this transaction has been mined. We can see that it was successful. We've got this green check mark here. These transfers that are happening are for the Chronos Protocol. One of them is the bounty, another is the fee, and the rest of it is going back to the owner of the contract. And then we see this token transfer here. And so this is the order that's being placed onto the matching market exchange. So it's sending 33 of the asset we want to sell because the price is going too low to the matching market so that we can buy the asset that we want instead. And in this way, we've implemented a decentralized autonomous stop loss using the Chronos Protocol and the Melonport fund. So let me jump back to the slides. And what else can we do with Chronos? So this is an example of a pretty straightforward use of a conditional, but the same idea can be applied to more complex trading strategies using on the decentralized exchanges, or even creating financial derivatives. So things like options contracts can be simulated using a scheduled transaction and a conditional based on a price feed. So you can also create mechanisms that watch states of contracts and react based on changes in those contracts. So let's say you want to watch a multi-sig, and when that multi-sig has a new owner added, you want some other transaction to happen. Maybe you want to send some ether to that multi-sig, for example. With the Chronos protocol and the conditional TimeNode, you can do that. And then, so the Chronos protocol is pretty ambiguous to the data that it needs. So basically, any Ethereum smart contract, any Ethereum transaction can be scheduled using it. So there's numerous other use cases, and it's whatever you can imagine. And like the alarm clock, one of the main goals is to be autonomous and watching the blockchain so that you don't have to and you can get a good night's sleep.
So you can find all the links here for GitHub and everything. You can find it here. You can also check out the Chronos protocol on GitHub on our ChronoLogic/Chronos page, and you know, you can also play around with this. You can also let us know if you have any potential use cases. If you you know, we are very inclined on helping anybody get started with building these types of mechanisms, be it the Ethereum alarm clock or the Chronos protocol. And we are always welcome. We also always welcome ideas and potential implementations and integrations that we could have with other protocols. So if you're a developer, even if you're not a developer, you know, feel free to try out all these tools and see if this is something that that you could use. We will keep in. We would like to kind of mention that, of course, the Ethereum alarm clock is very close to being released to the mainnet, whereas the Chronos protocol is still in the experimentation stage. So it is not yet production ready. So do not expect production quality tools to be built upon it just yet. But I think we can find many different use cases for conditional scheduling, and hopefully we'll have some really cool integrations and tools for you to kind of play around with that are a bit more user friendly. But for now, if you're a developer, you feel free to check out our GitHub page.
I'll also point out really quick that the code that I just demoed is available on GitHub as well. It's in the ChronoLogic slash Melonport Hackathon repository.
Awesome. So we can get into the Q&A. So if you guys have any questions, be sure to post them in the chat box, and we'll answer some of these. So I see we already have some of these coming in. So Mr. Swiss asks, for the AC time nodes, we know that a user sets a window to execute the transaction request. Will the Chronos TimeNode operate similarly, that it occurs in a window? Logan, I think you can answer this one, right?
Yeah, so the answer is yes and no. So with Chronos, you can choose to set a window of time where it's the execution window, just like in the alarm clock. But you can also set this execution window to be to start immediately and to last more or less indefinitely, so that you can, for example, in the conditional scheduler, it would it would basically turn off the idea of the execution window and just say that this is open to execution whenever the conditional is triggered. So as far as the temporal scheduling goes, yes, we still use the concept of an execution window. And for the conditional scheduling, it's optional.
But of course, for conditional scheduling, the idea is that you want something executed at this exact time, and since it is based on certain of these events, I think the great majority of the use cases would be without an execution window, so that they just happen as soon as their transaction gets included in the next block. So in mind.
Yeah. There's like a few cases of using an execution window with a conditional to kind of like simulate like a options kind of financial contract, where based on the price at a certain time in the future, you can do some kind of action. Maybe you'd want that to be delayed for a while. But I think the general use case will use the conditional and choose to opt out of the execution window.
Okay, so we have another question from Mr. Swiss. So, how would Chronos bounties work to earn for the time node? The time node could theoretically claim a conditional request, but maybe never earn a bounty from it if the condition is never met. Well, this is one of the risks that that the time node will be undertaking when claiming these transactions. What do you think about this, Logan?
So yeah, I'd say this is definitely a big thing. Like some time nodes may, depending on the claiming mechanism that we go with, may end up getting stuck with these. But there will be, at least in the current iterations, there's a way for a time node to opt out of a claim, or the claiming mechanism is still being formulated. So I think ideally we'd want a way for the time node to be able to say they don't want a conditional transaction, for example, or that if they get stuck with a conditional transaction, they can maybe choose to let someone else claim that, maybe for a small fee, and that way they're free to claim another transaction. But this definitely plays into what the final Chronos claiming mechanism will look like, which is still something that we're internally designing and figuring out and working with all of the economics and the game mechanisms behind to ensure that both the schedulers and the time nodes are getting a fair deal out of it. Okay, so Martin DeVries asks, does the Chronos protocol and associated functionalities need to be separately audited by ZK Labs or another auditor? And if so, do you have a time window of when that is going to be done? So we don't have a time window currently. So a lot of what is in Chronos is still up in the air. We don't have a formulated, we haven't formulated a claiming mechanism entirely yet, and it's still pretty far off from being in a state where we'd be looking for an audit for it. So the answer to whether it would need to be audited, the answer is yes. The time window when that's going to be done, I can't really speak to an answer right now.
Yes, we have to keep in mind that a lot of the stuff that we are introducing in the Chronos protocol shares some of the common issues that are being run into in other blockchain projects, such as I don't know, maybe like some other layer 2 technologies or some other, let's say, consensus, some other issues that require some kind of a different consensus other than the regular blockchain proof of work or something. So with this, it's kind of hard to estimate like what will be the ideal combination for this claiming mechanism to operate seamlessly, but we are working hard into kind of pushing out the final, let's say, the final proof of concept for it.
Mm-hmm. I just to really quick to echo that. So we are running into some of the same problems that are, I would say, unsolved problems of the space that there hasn't really been any solution for, namely the consensus issue. And so we're actively uh, looking and researching the most cutting edge things there. And uh, so it's hard to give like a timetable for uh, these problems that have yet to be solved.
And we are also communicating with other companies in the space and other people working on these similar problems, and kind of discussing with them, brainstorming, seeing if there are some things that they might have thought of and we haven't, and kind of to try to come to a kind of like a similar, or maybe like at least some clues to a solution to some of these consensus problems. So I think things have been moving slowly but surely. So we'll see how things will develop in the next couple of months. You're welcome, Martin. Do you have any other questions, guys?
If anyone has a question, get it in now.
Okay, thanks, Mr. Swiss. Thanks for the questions. Thanks, Martin. Okay, guys, I think that kind of wraps up today's live stream. So join us for the next live stream as well. where we'll have some other interesting topics to discuss with you guys. Hopefully, we can do a couple more that are related to the Chronos Protocol, so you guys can have a better idea of what we are up to and how the development and research has been going. Thanks very much, Logan, for demoing all the stuff that you did at Melonport. I think it was amazing what you guys did at the hackathon. As we've seen, as we've already mentioned, they won the grand prize. So the Melonport guys were very, very happy to see a mechanism like this kind of like stop loss mechanism using conditional scheduling, and we feel that this is like one of the prime examples for this type of decentralized, trustless conditional scheduling. So thanks again, Logan.
Yeah. Not a problem at all. I just want to say thank you to everybody who came to the live stream today, and hope to see you next week. And yeah, if you guys have friends, feel free to invite them.
Cool. Okay. Thanks, guys. Have a wonderful rest of the day.